before you and your group find it, doing a little activity. I don't know if you guys realize this, but to form a triangle, you cannot have any three side lengths you want. All right, so if I throw 2, 5, 20 up here, hate to break it to you, that's not a triangle. Won't form a triangle. Okay, it won't. It will not form it. It has to follow a certain rule. And that rule is what you and your group are going to find in our activity today. Right? So to form a triangle, the three sides cannot be any three sides you make up. It has to follow a rule. So to figure out that rule, you guys are going to help me out and do a little activity within your groups. First job in your activity. It says each member of the group should take turns picking 3 straws. What class are we in? We don't roll with straws in here. Okay, we don't do straws. Are you kidding me? That's a slap in the face to all of you. All right, we go much higher level, so we were going to be doing bags of or sticks of licorice here. All right, strands of licorice. So what I'm about to do right now, and you're going to act a lot more mature than period 4 was today. Right? When I put the strands of licorice in front of you, you are going to take a straight edge, and I'll get some straight edges out. You need to actually measure for me today. You are going to cut pieces 2, 3, 4, 5, and 6-inch strands for me, off of the 2 major ones I give you. Okay? Nick, you want to just go right behind around the dividers there? And just throw a couple, like 2 on each group here. Please do not eat these, all right, until we are done with the activity. Okay, until we are done with the activity, do not eat them. So once I give them to you, please start cutting the 2 through 6 inch pieces. Everyone, it's the whole group has that, all right? It's not each individual person needs to have those inch pieces. It's the whole group. So the whole group has a 2, a 3, a 4, a 5, and a 6 inch. All right, let's make this mature so we can understand what the rule is.
Do we cut it with the ruler?
I don't care how you cut it.
How are you going to cut it with the ruler?
Right? That's not my problem.
2 inches.
It's like you careful.
What is
that?
Brendan, I'd like to see
I
you
can
measure it with the same ruler you're going to cut it with.
That's why I agree every 4 rulers.
If I didn't give you, I think this should be enough. But if not, I can hand out.
Wait, did you do 3? Okay, I got 3.
Let's do this.
3's here. So we'll do
I'll do
3.
Here, I got
4.
That's true.
And 5.
Alright.
Now this
Does I not have enough? Everyone's got to have 3, I guess.
Right there. Boom, right here.
How do you cut this? Yeah, actually, Brendan, I don't know how to do this.
Then
Wait, what did you do? 2?
1, 6.
You did 6?
Alright, there we go.
Yeah, that's like $600.
Read that.
I'll do 5.
That's not.
No, because I got 6.
I'm doing 2.
It's closer.
This is like, alright.
I'm cutting one.
Alright, so here's the 6.
You guys aren't done yet? Yours are definitely not the right drawing.
Third.
This is 2. How do you only have 2 in here? That's true.
We got
Stop touching stuff.
we have a 6-inch and a 2-inch. That's not
I'm going 3 right now.
This is
That's perfect.
that's a perfect. Dude, this is. You think this is 3?
This is 3.
That's fair.
Alright, we have.
I'm good.
Wait.
Yes, good.
This one's just an extra one.
Okay, everyone got their pieces for the next part of the activity.
Yeah.
All right, next up, you are going to select 3 of your pieces. Jot the lengths down in the chart I provided in your notes. And you're going to tell me, hold on, if they form a triangle or not. Now, whoa. If they form a triangle, that means that's not a triangle if it comes up short. It's also not a triangle if it makes an exterior angle there. That's not a triangle. Like all 3 vertices have to be all 3 sides have to be touching all 3 vertices. All right. So here's what I need you to do next. Job number 2. Find me 3 sets that form a triangle. and then find me 2 that do not form a triangle. And then I'll proceed from there. Okay, so go ahead. Give me 3, and if there's controversy, call me over, I'll settle it. Okay, if it does or not. Pick 3, jot it down. See if it forms a triangle. I need 3 yeses and 2 nos before we move on.
Let's go 1, 4, 6.
If there's controversy, let me know. I'll let you know if it should or not.
What is that? Yeah, I guess.
Okay, yeah, just put it.
2, 5, 6.
Okay, what's this?
We did not.
That's 6.
We did not do 6.
4. Wait, let me just check. That's
That's 2.
That's should be 4.
Wait, when did we do 3? 4, 5,
So
4, 5, 6.
what was it?
6, 5, 6. What was that? Right?
Alright, ready? 2, 4.
Now we need 2 no's.
And then no. One more guess. So let's go. 3, 2, 3, 4, we did. 4, 5, 6, we did.
You can try it if you want to find more.
I don't know.
More yeses and maybe another no. It's up to you.
No, well, wait, we need a
There's
no,
only gonna be
so
so many
let's do
no's.
that.
Good.
Yeah.
Alright, 3, 5, 6. Wait, so we don't need to do the whole thing.
This one
No,
physically
no.
can't.
We can establish the pattern
Extends.
between 3 yeses
So
and 2
what's that?
nos.
That's 6. This is 1, 5 or 4. Why is this one 4.5? Oh. Whoopsies. Put that under.
5.
They're all.
There we go. There we go. Oh,
There should be
that's
2 bigger.
I don't know what that one's 3.5. Let's just say this one. Why is this one? Just keep this one 4.
How do you
Two times
What is it? 6, 4, 3.
4
3,
times 5?
3, 4.
Yeah,
Do we use that? We already used that.
I guess so.
2 times 4
We already used that.
That's right.
Well, because it was this one. So that's not right.
That's not right.
Oh,
This one's the 6. This one's
that's the 3.
3.
That's what it's
Oh,
It's
okay.
5 4 3 7. That's what it's on.
The 4.
All right, I'm going to have to move on here.
Yeah, it might have been like 5 4.
Can I have a group contribute a 3 lengths that did form a triangle? That did form a triangle. Emerson, start us off.
4 inches, 5 inches, and 6 inches.
Yep. 4, 5, and 6 that did form a triangle. That's a good one. June, you guys?
2 3 4.
Correct.
Yes.
How about another one? I asked for 3 here. If you don't have yours up here, Haley.
3 5 6.
Yep. All right, I have 3, but did Ava, go ahead.
2 5 6.
Yes. All right, I'll leave it at that. Now let's look at our no's now. Did anybody have a no one? Linus, what's good?
6 2 3.
2 3 6, yes. 2 3 6 should have been a no. That would not form a triangle. Others? Emerson.
4, 2, 6.
Correct. 2 4 6 did not. And there was actually one other combination. Anybody? Maybe I didn't list yours up here, Bryn.
5 2 3.
2 3 5. Yep. All right. So we have a lot of examples up here because here's the final job. Look at the ones that were a yes versus the ones that were a no. There is a rule for the 3 sides of a triangle that was followed for all the yeses, but was not followed for the no's, and that's why they're a no. So I'm going to let you and your group try to find that pattern. Why did these 4 end up making a triangle versus these 3 did not? All right, talk it over. Write down your thoughts. That's where it says summarize a conclusion. Write down your thoughts, and then we'll put an official theorem in the box once we're done talking. Write down your thoughts.
Well.
Doesn't have to be anything great. Just write down your thoughts.
I'm thinking that.
That's 14.
What do you have to know about all 3 sides of a triangle to make a triangle?
That's 15.
4 plus 5.
And that's 9. Actually, I thought it was with you add them up.
All right, got some thoughts written down before we make it official. So you guys now understand you cannot have any 3 side lengths and make a triangle. It has to follow.
Maybe the first 2.
It has to follow a rule, a theorem. I think my theorem's on the next page. It's got to follow a theorem called the triangle inequality theorem. Any group in their own words or thoughts? Michael?
The first 2 lengths have to add up to be more than the third length.
Yes and no. Yes and no. So you're saying, like, if I'm just going to start 5, 9, 4, something like that.
The 2 smallest lengths have to add up to be more than the.
Okay, so now we're getting a little bit more specific, which I like, and that's the way to cheat. Well, Michael just said if you add up the 2 smallest sides, it's got to be bigger than the third side. Yeah, yes, that's the way to check it. The official theorem is, though, any 2 sides added up. Any 2 sides added up have to be bigger than the third side. So here's our inequality theorem in a triangle. You know, we always have to start out with that because none of this works in an octagon, hexagon, quadrilateral. In a triangle, the sum of any 2 sides must be what? Must be greater than the third side. And notice my wording, greater than. Do you see the term or equal? No, it has to be greater than. And yes, what Michael just said is probably the way most kids check it real quick is if the smallest 2 aren't bigger than the third, then it's a no-go. Okay, it's a no-go. All right, here we go. Let's try a couple out here. We don't have many examples. Just to save some embarrassment to some of you, because this always happens, number 1 is not a multiple choice. It's 5 parts. We're going to go through each of them and say, would it form a triangle or not? 1, 2, 3. Form a triangle? No. Why not? Okay, no, whoa. I just want to make this clear. I know some of you could argue with me, well, wait a second. 3 plus 2 is bigger than 1, right? Which is true. But as long as you have one counter example, it's not a triangle. And what's that counter example? 1 plus 2 is 3. It's got to be greater than 3. Okay, so as long as you can find that one example that doesn't work, it's a no. How about 2, 4, 5? Will that form a triangle? Add up any 2 sides. Is it bigger than the third? Yep. How about 5, 5, 6? Would that form a triangle? Yep. And a little bonus, what type of triangle? Oh, look at you guys learning something this year. How about 8, 13, 21? Why not? 8 and 13 is 21. It's got to be bigger than the third side, which it's not. 10, 20, 25?
Yes.
All right, we're good there. Are you feeling confident in this theorem before I break your confidence down? We're good? All right, before I knock down your confidence a little bit right now. The other thing I want you to do with this theorem, other than tell me a yes or no if it forms a triangle, is tell me what could be possible third sides given two of them. So in this first example, I'm letting you guys know, hey, my first side is 4 inches. My second side is 7 inches. What are possible third sides? And what I want to do with you first, before I do an official answer, is I just want to give me a long list of different side lengths that it could be. And remember, it can't be anything, right? If somebody's going to tell me 100, I haven't been doing my job today. You don't understand the theorem, and I didn't do a good job explaining it. So what I want to do here is just go around, and you give me possible third sides so it fits into our sum of two sides bigger than the third theorem. What are possible lengths of the third side here? June, you going to start us? 4. Would 4 work, everyone? Let's see. 4 plus 4 bigger than 7. Yeah, 4 works for me. Brim?
5.
5? I believe 5 works. Yep. We're going to do this now. Go ahead. That's fine. 6 would work. Well, there's got to be an end to this so sooner or later. So hopefully people know where we're going to end and where. Maybe you don't. I don't know. How about 7? 7 okay or no? I know people get, oh, it's 2. I can't have 2 7. Yeah, you can. Right? 4 plus 7. Is it bigger than 7? Yeah. Okay. We're good. 8. Don't go by my tone. I could be just messing with your mind. 8.
Yeah.
4 plus 7 bigger than 8. 4 plus 8 bigger than 7. Okay. 9.
Yeah.
No.
Yeah.
Why not then? Just better have an example why. 10.
Yeah.
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 11.
Yeah.
No.
What's wrong with 11? It would be 4 and 7 is 11. It's got to be greater than that, right? So I guess that's where the train stops. Well, maybe. I didn't talk there. You know, June gave me 4. That's the first one I wrote down. What about 3? Let's go in the other direction. Would 3 work?
No.
Side of 3. Why not? 3 plus 4 is 7, not greater. So these are my only values. Now, I do not want you to, that's not my answer I want written here, is 4, 5, 6, 7, 8, 9, 10. Because this could get really, really long depending on the side lengths. What I want to do instead, I want my answer written as something you guys used last year in Algebra 1. I don't know if you remember, called a compound inequality, where you have 2 inequalities.
Yeah.
I'm going to put S in the middle. S represents my side. And then you're going to tell me the side lengths it should be between based on our work up here. Now, I'm going to warn you, don't write anything down yet because it might not be final.
Can we use the brackets?
No, we're not. You're thinking something different here. You're thinking like interval notation, stuff like that. I want it written as an inequality, though. What's going to be on my boundaries now? You want? I got 4 and 10, right? You want 4 and 10, but what are you going to tell me to? Because it could include 4 or 10, but that's not what this is saying. Oh, you want me to add those little lines underneath? I wouldn't. Time out. I'll do it. I wouldn't just put that officially yet. That includes all my numbers here, right? Everyone with me, honors kids? That includes 4, 10, and everything in between. I agree. Here's the issue. Could you please tell me if this works?
Yeah.
Could I have 3.9 as a third side?
Yeah.
What's 4 plus 3.9?
7.
Bigger than the third side?
Yeah.
Problem? It's not there, though. Doesn't fit there. Oh, I'm not done talking either. I'll let you go to your groups in a second. 3.9 does work, you told me, but it's not in your inequality. Should be. Let me do something else now. Ready? Does this work? Would 10.1 still be a correct side? 4 plus 7 is 11, bigger than the third side. But 10.1 doesn't show up in your inequality. Sorry. Go back to your group. I need something better than this right now. I need something better than that. All right, I need something better than that. So I can officially put something here. I'll assume by the silence that we have something better than between 4 and 10, including those. What do you got for me? What's better than that then? Between what instead? What are my boundaries? 3 and? Should I put the or equal to there? No, because it can't be 3 or 11. Wouldn't fit. Perfect. I love it. Great. That is our final answer there. That third side has to be between 3 and 11. You know what I don't like about it though? It took us so long to do that.
Yeah.
We had to write out every possibility. We did a rough draft of an inequality. It didn't work. We had to go back to our group. I didn't time it, but I'm going to say about 5 minutes it took us to do that one problem. That's ridiculous. I'm not spending that much time on one problem, and I don't expect you to either. So maybe there's a quicker way. Much quicker. Maybe 15 seconds, actually, could take us. Please go back. What were the original 2 side lengths I gave you guys? The original 2. 4 and 7. What was our boundaries for the inequality? 3 and? Given the sides, 4 and 7, is there any way I can probably find my boundaries a little quicker than the 5 minutes it took us? Is there a little trick to get me there much, much quicker? Eleanor, you think you got something there, young buck?
To find the least number, you subtract them. To find the greatest, you add them.
Perfect. All right, so if you want to know what it's got to be between, you take your 2 given sides, subtract them, and add them. Much quicker. Let's use that little technique on numbers 3 and 4 to finish this up. So now my sides are 9 and 17. 9 and 17. All right, so now that tells me my sides have to be between what's my lower bound down there, my lower side. 8, subtract them, but nothing bigger than 26. Yeah, that would have taken us forever to list out all those possibilities and figure out an inequality. And then finally, we'll end it here. 11 and 20 has to be bigger than 9 when you subtract them, but less than 31. Yeah, we're not writing out all those, huh? All right, so that's the quick way behind it. There's the quick way. All right, plenty of time. Plenty of time. You either have 2 options. You can eat the licorice while you work or throw it all away. It is your call. I don't care. I don't want it left on the desk or on the floor. So throw it all away or eat it. Your call.
Good patience.